Hello everyone. Today we are going to solve problem number 62, unique paths on LeetCode. So let's first read the problem. There is a robot on a M cross N grid. The robot is initially located at the top left corner, that is grid at index 0 0. The robot tries to move to the bottom right corner, that is grid M minus 1 and N minus 1. The robot can only move either down or right at any point in time. So the possible movements for the robot is either down or right. Given the two integers m and n, return the number of possible unique paths that the robot can take to reach the bottom right corner. The test cases are generated so that the answer will be less than or equal to 10 to the power 9. Okay, so the problem is quite straightforward. There is a robot standing at the index top right corner 0 comma 0, and it wants to reach the bottom right corner, that is m minus 1 and minus 1 index, and the possible moves are right and down. So how can we solve this problem? So earlier we have seen in the yesterday's problem that we can solve these type of problems using dp. So here the constraints are also very low. So what we can do is, suppose we have a function f, and we know that this function will give us the right result. So we will have two parameters I comma j, and if I comma j is invalid, so if it is an invalid index, so what we need to return is 0. The invalid index will be caused when our robot tries to move in, either say we can say down or here to the right. So if your robot reaches here or here, this will be an invalid index, and there are no ways, or you can say there are only 0 ways to reach the bottom right point. So this will be one of our base cases. Another base case will be when our robot reaches the destination, that is if I equals m minus 1 and j equals n minus 1. So in this case we will return 1. That means we have got one unique path to reach the corner. So what will be the answer when we are at ij? We simply need to return the, let me see here. So if we are standing here, what we need the result for this and result for this. The result for this will contain in how many ways we can reach the bottom from this point, and in how many ways we can reach the bottom from this point. If we combine the results of these 2 points, we will have the result for this point, because from this point we can only move to right and bottom. And if we have the answer for these 2 points, we will get the answer for current index. So we will return f of I plus 1 comma j plus f of I comma j plus 1, and later we can memorize it or tabulate it. So let's see how to write the code for this. So at first we will make a function, let's call it util. It will have two variables, int I, int j. We also need m and n at each step. So let's declare them here, int m and m. And here we'll initialize them. This m will be equal to the value of m for this function, and this n will be equal to n. So here I'm using a different concept. That is, I'm using this. So this points to the variables of this current function, or you can say this current class. So in this class we have declared m and n variables. So this at m will point to this m variable declared here, and the normal m will point to the m variable of this function only. So in this way we can use the same name for two different variables, and they can have different scopes and different values at the same time. And then we'll simply call from here util 0 comma 0. Then let's check for the base case. If this index becomes invalid, so how this index can become invalid? If either e is less than I less than 0, or j is less than 0, or I is greater than or equal to m, or j is greater than equal to n. If any of these cases are true, that means our index has become invalid, and we shall return 0 because there are no possible ways to reach the bottom if we have reached at any of those indexes. Then we'll have another base case, that is if I equals m minus 1 and j equals n minus 1. So this is where our destination lies. So we shall return 1 in this case. And for the rest of the cases, we'll simply return util of I comma j plus 1. That means we are moving to the right, plus util of I plus 1 comma j. So this shall run. Let's try it out. So you can see our sample test cases are passing, but we know that this will also increase exponentially because at each step we are breaking into two parts. So we need to memorize it, and here two parameters are changing, I and j both are changing. So we will require a 2D DP. So we'll make vector. Let's take long to be on the safer side. Long DP, and at each point we will resize the dp dot resize. It will be m comma vector of long, and initial value will be minus 1 because minus 1 cannot be the answer for any possible path. And then here after the base cases we will check if dp at ij is not equal to minus 1. That means this value was previously calculated. Then we simply return dp at ij, and if not, we will store the dp at ij value written by the answer. Now let's run our case. The sample test cases are passing. Let's check for all the sample test cases. So these are also passing. Now let's try to submit it. So we can see we are getting a accurate solution. So this was how memoization is done. So thank you and see you in the next video.